Let's do a code review to examine the Python code that we executed to detect when our button was being pressed. At the beginning, we first import the rpi.gpio library, and we've seen this before. This allows us to interact with our GPIO pins programmatically and take readings and so on. Next, we import the time library, and again, we've seen time before. Time allows us to sleep for certain periods if we want to introduce some polling or waiting in our program. Next, we define a variable called button pin, and we set that equal to 16. And remember, when we were wiring up our circuit, pin 16 was connected to our button, and the other pin on the button was connected to ground. So that is why we set it at the value of 16. Next, we do gpio.setMode, gpio.board. And remember, we're using the board mode because our numbers are being referenced by physical location, and that's why we're able to set button pin equal to 16. Next comes a line of code that we haven't seen before, but essentially we're doing a gpio.setup. We are saying here, set up the button pin as an input. So we have the second argument in that function is gpio.in. And here we are enabling the pull up resistor. So pull up down is equal to gpio.pud up, and that's essentially the pull up resistor that we are enabling. Now, the pins on the Raspberry Pi have pull up and pull down resistors, and a pull up resistor actually pulls up the value of that pin if you were to take a reading to high. If it were a pull down resistor, if you were to take a reading on that pin, it would be low. So by default, it will be high. And in our circuit, when we close the contact on our button, current flows from our pin 16 through our button to ground. And that internal resistance, or that pull-up resistance, limits the amount of current that flows through our button and through our circuit in general, and that prevents the Raspberry Pi from being damaged and a large amount of current, a short, from that happening. So we could have added an external resistor in our circuit, but just to simplify the components, we used here in this program the internal pull-up resistor to simplify things. So it's very handy, and it's a good tip for you to use in your projects. Next, in the main meat of the program, after we have done our initialization in our while true loop, again, while true simply runs indefinitely and loops over and over again once there's power applied to the Raspberry Pi and of course your program is running. So first, we take a reading of that button pin. So we set a variable input state is equal to gpio.input button pin, and basically that's going to retrieve if that pin is high or low. And if the input state is false, that means that the button was pressed. In its default state, if we were to read it, that value would be true or high because we have pulled up that pin to high using our internal pull-up resistor. But once the button is pressed, that value is going to be low as current is going to be flowing through our pin and connected to ground, and that's why that value would be false now. Now that verifies that in fact our button was pressed, and we do a print button pressed, and that shows up here in our shell. We do a time.sleep for about a third of a second, and then we continue on. Now, the reason why we do a time.sleep is that in electronics, there is a concept called the bouncing. And what happens is when you press a switch, because of physical contact is involved, it actually makes contact 3 or 4 times in less than half of a second. And that is called the bouncing. So in order to eliminate a false reading, we simply wait for about a third of a second, and if any bouncing happened, that would have passed, and then we continue on reading the state of our button to determine if it's pressed. So that is our program. It's very short, but quite a lot is going on in here, and hopefully you understand the code that's involved and you can incorporate buttons now in your Raspberry Pi projects.